Alrighty, Secondary Math 2. We are going to be doing our first final review for our final today. Alrighty, so we are going to go over basically a majority of the first half of the year, what we've learned, what we've talked about, everything that's going to be on your final in a couple classes. Alrighty, so the very first thing, if we went back to the beginning of the year, we talked about exponent rules. Okay, so for number one, it's just telling us to simplify. Your answer should contain only positive exponents. Okay, so let's go ahead and remind ourselves of our exponent rules that we're dealing with. So we actually had 5 exponent rules. Okay, our first rule was our product rule. Okay, in the product rule, that's where the bases of the exponents are being multiplied. Okay, and what you do here is you add the exponents. Okay, then we had our quotient rule. Okay, that's where they're being divided. And this one you can either think subtract or cancel the exponents with the same base. Remember, they always have to have the same base. Okay, then we had our zero rule, which says anything to the 0 power, so I'm just doing x, but it's anything to the 0 power is 1. Okay, then we had our negative exponent rule. And this one, think switch places. So if you have a negative on the numerator, it has to switch to the denominator and vice versa. And then our last one was power to power rule. So this is like where you see parentheses and you have an exponent, but it's to the power of something. Well, this is where you multiply the exponents. Okay, so that was just a quick 5-second refresher on all of the exponent rules that we talked about. Okay, so let's go ahead and look at number 1. Okay, so the great thing about exponent rules is it really doesn't matter what order you solve them in. Whatever you see first is what you can simplify. Okay, well, the first thing that always jumps out to me are parentheses. Okay, so that means I'm going to take whatever the exponent on the outside of the parentheses and it has to multiply, this is our power to a power rule, to everything inside. Okay, every base. So we have an x and a y. Okay, so x to the power of 0 times 0 is 0. Y to the power of negative 2 times 0 is also 0. Okay, and then we can just put what was out front. And then we had an x, y to the negative 1. And now it's all just being multiplied. Okay, so we have a couple more rules to go ahead and simplify. Okay, well, the next thing I see are these zeros. Remember, anything to the 0 power is 1. Doesn't matter what it is. If it's to the 0 power, it is 1. And multiplying anything by 1 doesn't change it. So what we do is we just get rid of them. So now all I have is x, y to the negative 1. Okay, well, I cannot combine the x and the y, but remember, your answers, if you have any negative exponents, you know you're not done simplifying. So this negative 1 grabs onto its base, which is the y, and it moves it to the denominator, which technically it's over 1. Okay, so our final answer is going to be x on top and y to the positive 1 on bottom. So x over y. Okay, cannot combine those guys anymore. That is all simplified. Okay. For number 2, we are simply talking about solving an equation. Okay, we've been solving equations, solving for a variable since the first day of last year, right? We've been doing this for a while. Okay, so whenever you see parentheses though, like you do right here, you have to use the distributive property, which means you take the number in front and it has to distribute or multiply to everything inside. Okay, so negative 4 times 4 is going to give me negative 16. Negative 4 times negative 6x is going to give me a positive 24x. Okay, so that's that side of the equal sign, and then we can just copy down the other side, 5x plus 3. Okay, So remember, in order to solve for x, we're trying to figure out what number x represents. Okay, we need all of our x's on one side. I have 5 on this side of my equal sign and 24 on that side. I need them all on one side. I like moving the smaller amount, so I'm going to go ahead and move 5x. I do this by the opposite of positive 5x is negative 5x, or subtract 5x. And I combine it with the x's over here. So I'll go ahead and just rewrite it over here to give us some more space. We have 3 is left on this side of my equal sign. Negative 16, which we didn't affect at all. 24 minus 5 is positive 19x. Okay, so now that all of my x's are on one side of my equal sign, I can go ahead and solve it. So we look at our side with our x. I need to get rid of the negative 16 first because it's farthest away from my x. Okay, so I do the opposite, which is to add 16. Okay, so I get 3 plus 16 is 19 equals 19x, or 19 times something is 19. You might already know the answer. Okay, so now we do the opposite of times by 19, which is divide by 19. So I get x is equal to, and yes, I switch the x to the other side. That's okay. You can always switch sides of the x's. Doesn't matter when you get your final answer. 19 divided by 19 is positive 1. So x is equal to positive 1. Beautiful. Alrighty. Okay, for numbers 3 and 4, it's asking us to simplify. Notice there's no equal sign. Whenever you see an equal sign, it'll say solve. But when there's not an equal sign, it is to simplify. Okay, so this is where we're adding and subtracting polynomials. Okay, so we had a couple rules when adding and subtracting. So let's go ahead and write those down. When you are adding the polynomials, you see an addition sign. The signs stay the same. Okay, and we'll remind ourselves what that means. When you see a subtraction sign in the middle, the signs are going to change after that subtraction sign. Okay, so let's go ahead and look at number 3. Okay, so look at our sign in the middle. We are adding these guys. Okay, well, what this really means is if we're adding, the signs stay the same, but it's just distributing or multiplying to all the signs inside, and multiplying by a positive doesn't change anything. So here's the great thing. We just copy down. You can always copy down the first one. That guy never changes, so 8p squared minus p to the 4th minus 2p cubed. Okay, well, since these guys' signs don't change, this is a positive 3p cubed, a negative 5p squared, and a negative 2p to the 4th. Okay, so now in order to simplify this guy, we just need to combine like terms. Remember, in order for it to be a like term, it needs to have the same variable, which these all have p's, but they need to be to the same power. Some are squared, some are cubed, and some are to the 4th power. You can only combine squareds with squareds, cubes with cubes, 4th power to the 4th power. Okay, so first one I see is p squared, so I have 8p squared. I can only combine that with another p squared, which there we go. So 8p squared minus 5p squared is going to give me positive 3p squared. Okay, then I'm just going to go in what we call descending order. I'll go to cubes next. Okay, so I have negative 2p cubed, and I can combine it with my other p cubed. Negative 2p cubed plus 3p cubed is going to give me positive 1p cubed. Remember, we don't have to write that 1 in front. We always can just assume that there's a 1 there. Okay, and my last one is fourths, so I can combine my p to the 4ths now. I have negative 1 p to the 4ths, and I'm subtracting 2 p to the 4ths. Well, that's going to give me negative 3 p to the 4ths. And there's our final answer. It's simplified, there are no parentheses, and there are no more like terms because they don't have the same powers. Okay. Now I'm going to change number 4 just to give us another example. So I'm actually going to change this from an addition sign to a subtraction sign. Okay, so go ahead and do that on your notes as well, just so we can see both examples. Okay, well now that I change this to a subtraction sign, now the signs after are going to change. Okay, so remember you can always just copy down the first one. That one never changes, so 2 plus 4x plus 7x to the 4th. But now all of these signs inside change. So this was positive 3x to the 4th. Now it's negative 3x to the 4th. This was negative 2x. Now it's positive 2x. And this was positive 5. Now it's negative 5. Okay, so there's an example of when the signs would change. Okay, but now in order to simplify, we need to combine. Okay, so I'm going to go ahead and start with my highest power. We'll just start with 4's first, x to the 4ths. Okay, so I need to find my other x to the 4th right there. So now I have 7x to the 4th minus 3x to the 4th. 7 minus 3 is 4x to the 4ths. Okay, then I'll go with my x's next. I have 4 x's plus 2 more x's. That's going to give me positive 6 x's. And then my last one are just my constants, my numbers. 2 minus 5 is negative 3. And there we go. Okay. So those were simplifying, adding, and subtracting what we call polynomials. Alrighty. Okay, so for numbers 5 and 6, we are sketching the solution to each system of inequalities. Okay, so system of inequalities. So first we have to graph these, and then we are going to find the solutions. Okay, so first of all, we are going to treat these just like as if they were equations, not inequalities, to start off with. So let's just start with our purple guy. Okay, so these are all written in slope-intercept form. So slope and y-intercept are going to help us graph this first purple guy. So my slope is in front of my x, slope of negative 2. My y-intercept's on the end, negative 1. Okay, so we can go ahead and graph this guy. I'm going to find negative 1 on my y-axis because that's my starting point. And then my slope is negative 2. So down 2 over 1, down 2 over 1. And you can go the other way too, up 2, back 1, up 2, back 1, up 2, back 1. Okay, now here's where it gets a little different. Okay, so usually we would connect these dots, which we are going to, but we need to remember our rules. Okay, if we have just a greater than or less than sign, it's going to be a dotted line. If it's a greater than or equal to or less than or equal to, it's a solid line that we connect them with. Okay, so let's look back at our purple one. This is greater than or equal to, so I'm going to connect them with a solid line. Okay, now we're still not done for this guy. The next thing we need to do is shade. Okay, so I'm going to shade, let's go ahead and just color with the purple, yeah. Okay, so this is saying now, y is greater than or equal to. So we want to shade where the y's on our y-axis are getting bigger or greater than. This means I would shade up. So I'm going to shade everything to that side. And there we go. We have our first inequality graphed. Okay, well now we need to graph our second inequality. We'll do this one in green. So again, we need to identify our slope and our y-intercept. Slope is in front of the x, which is just a positive 1. Y-intercept is positive 2. Okay, so we start with our y-intercept, so find positive 2. It's going to be right there. And then we have a slope of 1. So positive 1, up 1, over 1, up 1, over 1. We can go backwards, downward, back 1, down, back, down, back, down, back, and down, back. And one more right there. Okay, so we have our points. Now we just need to decide how are we going to connect them. Is it going to be an open or a dotted or a solid line? Okay, these guys is going to be a dotted because it's just greater than. Okay, so dotted line, I'm connecting it with, there we go, arrows at the end, beautiful. Okay, now for this guy, I also need to shade. So again, this is saying y is greater than, so I need to shade where my y's are getting greater than that green one. So it would be shaded everything above the line. Now the solution to this system of inequalities is this dark spot where they're both shaded. So any point within that darker shaded spot is a solution. Okay, so let's try that again. Okay, so let's look at our first inequality, this guy. So I want to identify my slope and my y-intercept. My slope this time is -1, and my y-intercept is +1. Okay, so I can find +1 on my y-axis, right there. And I have a slope of -1, so down 1 over 1, and I can keep going, down 1 over 1, down 1 over 1, and I can go backwards, up 1, back 1, and there we go. Now, what are we going to connect these guys with? A dotted or a solid line? Okay, because there's no line underneath, it's going to be a dotted line. So we connect it with a dotted line, arrows at the end. And now we need to decide where we're going to shade. This is saying y is less than. So we need to shade where the y's are getting less, which would be down. Okay, so for my purple guy, it shaded everything down. Okay, now our second guy. So again, identify slope and y-intercept. So I have a slope again of -1 and a y-intercept this time of -2. Okay, so find -2 on your y-axis right there. My slope is -1, so -1, -1, boom. Go backwards, right there and there. Okay, so I have all my green points. Now I just need to decide, do I connect them with a dotted or solid line? This one does have the line underneath, so it is a solid line. Okay, now we need to identify where we're shading. Again, this is y is less than or equal to, so y's that are less than would be everything below, which would mean this whole dark area would contain solutions to this system of inequalities. Okay, awesome job. Let's go ahead and go to our next page. Alrighty, so for numbers 7 and 8, we are asked to find the product. Okay, whenever you hear the word product, that means you are multiplying. Okay, this is what we call multiplying binomials. We learned 2 different methods for multiplying binomials. Okay, the first method, which we'll write over here, if you remember it, it was FOIL. Okay, well, FOIL stands for first, outside, inside, and last. First, outside, inside, and last. Okay, so the other method that we use, and we'll use it on number 7 just to give us some more room, was the box method. The box method is literally where you draw yourself a box with 4 squares. Okay, and what we're going to do is we're going to put our first binomial across the top, so 2x and +2. And then we're going to put our second binomial down the bottom, or the side, excuse me, 2x and a +7. Okay, now if you remember, we just fill in the boxes by multiplying what they line up with. So my first box lines up with 2x times 2x. Well, that's going to give me 4x squared. Okay, my next box, 2 times 2x is 4x. Next box down here, 2x times 7, 14x. And 2 times 7, 14. Now that we have all 4 of our boxes filled in, we can just rewrite it over here. 4x squared plus 4x, so I'm rewriting it in the order that I solved it, plus 14x plus 14. Okay, now we're not completely simplified because we have some like terms that we need to combine. So the like terms that I need to combine are the ones with just 1 x's. Okay, so 4x squared stays the same, but 4x plus 14x can be combined. That's going to give me 18x and plus 14 on the end. And there is our product, our final answer. Beautiful. All right, let's look at number 8. Okay, so let's go ahead and use FOIL for this one. Okay, so FOIL, we're going to multiply the first ones first, my first terms of each binomial, 7m times m. Okay, so 7m times m is going to give me 7m squared. Okay, then I go to my O, which is outside. So my outsides are 7m times 2. Okay, well 7m times positive 2 is positive 14m. Now I'm going to my I, inside terms, negative 1 times m, which is just negative 1m. And L, my last terms, negative 1 times 2, negative 2. Okay, so we just followed the pattern. Multiply your first, your outside, your inside, then your last. Okay, same thing as the last one. We're not fully simplified because we have some like terms we can combine. So where are the like terms? Well, if you followed FOIL, they'll always be in the middle, the ones with just the 1m. So 7m squared stays 7m squared. 14m minus 1m is going to turn into 13m. And negative 2 on the end. And there's our final answer. Beautiful. Alrighty. Big part of secondary math 2 coming up now. We are now asked to factor. Okay, for 9 and 10, we're asked to factor out the common factor of each expression, which means both terms have something in common that we factor or divide out. Okay, remember, whenever you hear the word factor, what we're actually doing is dividing. Now, it's kind of like going backwards of what we were just doing. Okay, so let's look at number 9. I'm actually going to zoom in just a little bit. Okay, so for number 9, we look at our terms. Okay, so I have 12n and negative 2. Okay, well, let's first look at our numbers. Okay, 12 and negative 2. And we're actually not going to worry right now that it's a negative 2. So just think 12 and 2. Okay, well, what number, or what is the biggest number, in other words, the greatest common factor, the number that I can divide both 12 and 2 by and get an even or a whole number out? Okay, well, I know that 2 goes into 2, and 2 also goes into 12. Okay, so that means I can factor out a 2. Okay, when we factor out, it comes outside, and then we divide it to see what we're left with. Okay, so we can factor out a 2, which means we're dividing by 2 on each one. 12 divided by 2 is 6, and we'll worry about the n in a second. Negative 2 divided by 2 is negative 1. Okay, well, now I need to worry about this n. We can only factor out the n if they both have at least an n. Okay, well, my first term has an n, my second term doesn't, so we cannot factor out that n, so it has to stay inside. Okay, so our final answer is just 2 times 6n, whoops, and I totally just wrote m, n minus 1. And there's our factored expression. We factored out the common factor, which was 2 in this case, because 2 goes into 2 and 12. Okay, let's look at number 10. Okay, so now my numbers are 24 and 9 that we're going to worry about first. What is the number that I can divide both 24 and 9 by? Okay, well, first of all, let's just see if we can divide 24 by 9. Maybe we can take out the 9. We can't. We get a decimal. Okay, so we're going to have to go smaller than 9. Okay, well, I know I can divide 9 by 3, so let's see, 24 divided by 3. Oh, yeah, okay. So they both share a 3 that can go into them, so 3. Okay, gets factored out, which means what we're actually doing is dividing by 3 for each of these guys. 24 divided by 3 is 8. We'll worry about the r in a second. Positive 9 divided by 3 is positive 3. Okay, now let's worry about the r. Do they both have any r's that we can factor out? No, only my first term does, so we cannot factor out the r. It does not get to come out. So our final answer is 3 times 8r plus 3. We factored out the common factor, which was positive 3. Okay. Sorry about the bell. Alrighty, let's look at numbers 11 and 12. So now we're still factoring, but if you remember, this one's kind of a little bit of like a number game. Okay, so we have 3 terms here. This is what we call a trinomial. Okay, and there's nothing that all 3 terms have in common, like these 9 and 10 ones, that we can factor out. So we have to play the number game. If you remember, the number game goes like this. What 2 numbers are going to multiply to your C, but add to your B? Okay, so let's go ahead and write down that question. Remember, this was our $1 million question. What 2 numbers multiply to C, which is your last term, and add to B, which is your middle term? Okay, so let's look back at number 11. So we're trying to find 2 numbers that multiply to give me negative 54. Well, let's just go ahead and try to find some numbers. I have 9 and 6. But because it's a negative 54, one of them has to be negative. So let's just make the 9 negative. Why not? Negative 9 times positive 6 will give me negative 54. Now let's see what they add up to. Negative 9 plus 6 gives me negative 3. Ooh, we're really close to positive 3, but that's not what we're looking for. So maybe let's try switching the signs. Positive 9 and negative 6. Well, 9 minus 6 gives me that positive 3 that I'm looking for, so I found the 2 numbers. Okay, once you've found your 2 numbers, it's pretty simple at this point. You just add them into the factored form. Okay, give yourself 2 sets of parentheses, kind of like on 7 and 8. Now we're just going backwards. Put your variable in front, so x and x. And then we add a positive 9, so plus 9, negative 6, so negative 6. And there we go. Alrighty. Okay, number 12, same thing. We need to play the number game. So look at your last number. What 2 numbers multiply to 72 but are going to add to negative 17? Okay, let's just try getting some numbers for 72. 72 divided by 12. Okay, 6, we can always try it. Let's just try it. 12 and 6. So 12 times 6 will give me 72. Let's add them up. 12 plus 6 gives me positive 18. Definitely not what we're looking for. That's okay. Let's try it again. Maybe 72 divided by 4. 4 and 18. 4 times 18 will give me 72. 4 plus 18 is 22. Not what I'm looking for. Let's see. Maybe 72 divided by, let's try 6 maybe. Oh, we already did that. 6 and 12, we got that. 72 divided by 9 and 8. Okay, 9 and 8. 9 times 8 will give me 72. 9 plus 8 gives me 17. Positive 17, it's really close. We're looking for a negative 17. So still not quite what we're looking for, but we're close. But remember, a negative, if we just put the negatives on these guys, negative 9 and negative 8, a negative and a negative still multiply to give me a positive. So that's why we can do that. Now I have negative 9 minus 8, which gives me my negative 17. So I found my two numbers. Now I just need to put them in factored form. Okay, so I have my two sets of parentheses. My variable goes in front. This time it's n and n. And minus 9 for negative 9. And minus 8 for negative 8. And there we go. Okay. Numbers 13 and 14. Now it's telling us to solve each equation by factoring. Okay, so now we have an equal sign for these guys, and we're going to factor and then solve. Okay, well, the golden rule when solving by factoring is that they must equal 0 to solve. Let's write that down. Must equal 0 to solve. Okay, right now this doesn't equal 0, it equals 5. Okay, but we can make it equal 0. So what I'm going to do is I'm going to just move this 5 over by doing the opposite. Negative 5, and that'll move it to that side. Okay, so now we're just going to rewrite it as n squared plus 4n, that was over there, minus 5 on the end, and guess what? It now equals 0. Now we can play the number game with this guy. What two numbers multiply to negative 5 and are going to add to positive 4? Okay, well this one's kind of easy because there's only really one option to multiply to get to 5. And it's got to be 5 and 1. Okay, but to get a negative, one of them's got to be negative. Okay, I'm just going to make the 1 negative because what is 5 minus 1? It's positive 4. Beautiful. So I found my two numbers. Now I can just put it in factored form. Okay, we're doing the same thing as we did last time. So now I have n, again, n and n. This time positive 5 and negative 1. Here's where it becomes different. Now it equals 0. So what we have to do to solve is we have to take each piece, set it equal to 0, and solve for that n. So n plus 5 equals 0, and n minus 1 equals 0. Okay, well now we do the opposites. So now my opposite of positive 5 is negative 5. So my first answer is n equals negative 5. Second one, opposite of negative 1, positive 1 to both sides. And my second answer, positive 1. Okay, if you remember when we did this in class, your answers are just the opposites of the two factors that you found, right? So I found that my factors were positive 5 and negative 1. Well, my answers are negative 5 and positive 1. Okay, so let's go ahead and do that again. Okay, remember, it must equal 0 in order to solve. It does not equal 0 right now, but we're going to make it equal 0. Remember, don't move whatever is squared. Keep that on the same side. Move everything else to that side. So I'm going to move this positive 16. I do that by subtracting 16. So now I have k squared plus 6k minus 16 equals 0. Okay, now I can play the number game with this guy. What two numbers multiply to negative 16 and add to positive 6? Okay, well, I know that, let's see, we got 4 and 4, but it's got to be a negative, so maybe 4 times negative 4. But that's going to add to 0, so that's not what we're looking for. Maybe 2 times 8. One of them's got to be negative, maybe negative 8. That's going to give me negative 6. Ooh, close. We're wanting positive 6, but that's not quite what we're looking for. So maybe let's try negative 2 and positive 8. That adds to positive 6, so we found our two numbers. Okay, once we find our two numbers, put it in factored form. So this time it's k minus 2, and k plus 8. Now here's where it's different. They equal 0. Okay, well now we're going to take each piece. K minus 2 equals 0, and k plus 8 equals 0. Take each piece, set it equal to 0, and solve. Opposite of negative 2, positive 2. So my first answer is, and you can write it like this as well, positive 2. Second answer, opposite of positive 8, negative 8. 0 minus 8 is negative 8. And there are my two answers. Again, just the opposites of what we found as our factors. I found my factors to be negative 2 and positive 8, which means my answers, positive 2, negative 8. Just change the signs. Okay, so that was where we're solving what we call quadratics by factoring. There is another way to solve quadratics, and this way is not the nicest way, but it'll always work, okay? So this way is using the quadratic formula. So let's go ahead and remind ourselves what the quadratic formula is, okay? So quadratic formula, x, why am I doing it in black? Let's do it in red. X is equal to negative b plus or minus, that's where we get our two answers from, square root of b squared minus 4 times a times c, all over 2 times a. Okay, so let's go ahead and look at number 15. So in order to plug it into our formula, we have to identify a, b, and c. Remember, this is just in standard form, which means our a is that 1, b is negative 5, c is negative 24. Okay, so now what I'm going to do is I'm going to just rewrite my whole formula, but leave little spaces. So I have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay, well now I just left little spaces because I can plug in what my a's, b's, and c's are. So the first comes b, so negative b, my b is negative 5, b again, negative 5 minus 4 times a is 1, c negative 24, all over 2 times a, which is 1. Okay, it looks really messy, but we're going to go ahead and solve it piece by piece. The first piece, if you remember, is the discriminant. I'm just going to solve this piece. Okay, so slowly going to get a little smaller. So we have negative 5 times negative 5, or negative 5 squared. Well, that's going to give me positive 25, just that little piece right there turned into 25. And now I can multiply negative 4 times 1 times negative 24. And I'm just going to do that in my calculator. Negative 4 times 1 times negative 24. And I get positive 96. So 25 plus 96. Definitely doesn't look as ugly. Okay, well, let's look at our front piece. Whenever we have this double negative here, it turns into a positive. So now I have 5 plus or minus the square root of 25 plus 96, and it's all over 2 times 1, which is just 2. Okay, so now I need to do some more simplifying. So first of all, what is 25 plus 96? 25 plus 96 gives me 121. So I'm just going to rewrite this over here. We have more room. We still have x is equal to 5 plus or minus. Now it's the square root of 121 over 2. Okay. What is the square root of 121? Okay, this is going to give us a nice number. Square root 121 is 11. So now I have x is equal to 5 plus or minus 11 over 2. Okay, and this is where our two answers come in, and we're actually going to skip number 16 because we're taking its space, no worries. All right, so this is where our two answers come in. Okay, so I'm going to draw 2 arrows here. So our first answer, x is equal to 5 plus 11 divided by 2. And our second answer, x is equal to 5 minus 11 over 2. We just split up that little plus or minus sign. Okay, so let's go ahead and solve this guy. So 5 plus 11, 16, divided by 2. Well, 16 divided by 2 is positive 8. There's my first answer. Second answer, 5 minus 11 is negative 6, I believe. Let me just double check that. Yep, negative 6 divided by 2. Well, that's negative 3. So my next answer, or my second answer, is negative 3. Okay, now, because we got 2 nice whole numbers, this means this guy could have been factored. Yes, you could have solved it way quicker using factoring, but that just goes to show that quadratic formula will always work. Okay, on this guy, you probably wouldn't have gotten something super nice here. That's okay. Punch it into your calculator and you'll get a decimal. Okay, and that's totally fine. But that is your first review, and there's an assignment that goes with it.